These questions are all taken out of some exams from, I believe, a mix of year 11 and year 12. Okay, so some of them come from different resources, and they all vary in difficulty. Okay, so not all of them will be hard, but not all of them will be easy either. All right, so I'm gonna leave question one because if you read the question and you do it, you can actually, yeah, it's pretty easy. Okay, so I'll leave that. Question two. Okay, we'll do question two because it does require a little bit of thinking. So in this question, it says in total 40 dogs. Key number there. There's 40 dogs related to this question. Attended various training classes held at a park last week, and the histogram shows the distribution of their weights. Okay, so it's talking about dogs and their weights. What percentage of these dogs weighed more than 18 kilograms? So more than 18, you'd have to look at the histogram's weights. Okay, and where is 18? Well, I can see 18 is right here, and this is the frequency for all of the ones above 18. And I can see that the frequency, if you look at where it lines up, there's one. So that means together there's two. Okay, and the question states that there's 40 dogs. So that means 2 out of 40 dogs, okay, are 18 kilos. And as a fraction, simplified, that'll be 1 out of 20, which is, I'll put in my calculator. I think 5%. Oops. So 1 divided by 20 should equal 0.5. Well, control, yeah. So 5%. Oh, sorry. How did I get from 5%? Well, this is a decimal. Just multiply it by 100. Okay, so times 100 gives you 5. So 5% of the dogs weighed more than 18. Which interval does the median of the distribution lie? Okay, now this one's a bit tricky, but you got to figure out where is the middle number, or in which interval, as in which of these intervals here will your median lie. Now your median, remember, is the middle number. Okay, and the middle number you can find using the formula n equals, median. I'll write this down because you might have forgotten this. Learned this back in term 1. N plus 1 divided by 2, where n refers to the number of numbers. Okay, so in this case it's going to be 40 plus 1 divided by 2, which equals 20.5. Okay, now that itself is not the median, it's just the position of the median. So if you count numbers here of the 20.5th position, so you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.5 would be somewhere in here. So that means the interval that has the median is here, between 6 and 8. Okay, 20.5 is in there somewhere. Okay, so the interval 6 to 8. Okay, it's asking us which interval will you find the median. And generally, when you get a question like that, you'll find that the interval that has the mode as well, so the modal interval, is also where the median might be. Okay, because it's where most of the data is found. Okay, describe the shape of the distribution. So this one here starts high and then it goes down. So the tail is on this side, which means that the shape is positively skewed. Okay, if it was the other way around, as in the data looked like the opposite, so it was like this, and then it went up, and then like that, then it's negatively skewed. But it's not, because it follows this pattern. Okay, so it's positively skewed. And the data for the distribution, the data values for the distribution are available in a frequency table. State whether the mean or median is better for a measure of center. Give reason for your distribution, for this distribution. Now, remember, when it asks you whether the mean or median is better, okay, keep in mind that if your data is approximately symmetrical, okay, symmetrical. So just keep this in mind. Okay, it's good to use mean or median. Either is fine. Okay, because it's symmetrical, you can actually use the middle number or you can use the mean that's given as a measure of center. But if your data is skewed, so whether it's positively or negatively skewed, use the median, okay, as a measure of center. This is because if it's skewed, it's probably going to have like outliers here of some sort. Okay, so it's better to use the the median if your data is skewed. Okay, so in this case, when you give a reason for this question, the median, okay, is better, is an ideal, okay, measure of center. Okay, sorry for the handwriting. And your reasoning would be because the data is skewed. Okay. All right, nice and easy. All right, so just keep this in mind whenever you get a question that asks, is the median better or is the mean better? Just look at the skew. If your data is skewed, use median. If your data is symmetrical or approximately symmetrical, mean or median is fine. Okay, let's keep going. Let's see, this one here, question 3. All right, I'll do a little bit of question 3. So this parallel box plot. Now, when you get parallel box plots, you're probably going to be comparing them. Okay, it's a question where you're probably going to need to compare something. Okay, but you'll also need to look at the values and make some assumptions and whatnot for it. But let's look at this. So the box plots show the distribution of dogs that attend training classes each weekend. So it's comparing between 2017, 2018. Okay. Complete the 5-number summary for the distribution in the table below. All right. So for number of dogs, and this is just for 2017. Okay. Some of you might get confused and think, oh, which one am I looking for? Read the question. Okay. Read the question. It'll always tell you what you need to do. Here you're looking at 2017. So I'm just going to focus on this box plot here. Okay. So minimum for 2017. Some of you might think that the minimum is right here. Okay, that's not technically the minimum. Okay, even though this outlier is an outlier, it's still the minimum. Okay, so in this case, that lines up with 26. So the minimum is 26. Median in your box plot is the line in the middle of the box itself. Okay, so that's pretty straightforward. It looks like that would be 39. Okay, nice and easy. Done. Okay, determine whether what's the value of the lower fence for 2017. Okay, so looking for the lower fence. You don't even need to look for the upper fence, just the lower fence. Okay, so I'll do the lower fence formula. If you forgot it, it's Q1 take away 1.5 times the IQR. Okay, so in this case it would be, let me change the colors. So that would be 35 take away 1.5 times. Now, IQR, you determine by going Q3 take away Q1. So I'll put that here. Okay, Q3 take away Q1. Don't forget that. So that would be 40 take away 35, which is pretty straightforward. So 5. So times that by 5. So on my calculator, let's get it out. Let me put this here so you guys can see what I'm doing. So you'll be going 35 take away 1.5 times the IQR of 5. Okay, and that'll give you the lower fence, which is 27.5. So therefore, anything below 27.5 is an outlier. And I can see that 26 is definitely an outlier because it's below 27.5. Using your answer to part 1, explain why when 26 dogs attend the training classes is an outlier. Oh, I just mentioned that. Okay. Well, you would state because, well, actually, you'd write 26 is an outlier. Is an outlier because it is lower than the lower fence. It is, or you can say it is beyond the lower fence. The lower fence. Okay, and you know that the lower fence is 27.5. Okay, so if it's below that, then it's going to be an outlier. Okay, use an appropriate statistic to compare the spread. Okay, this is pretty straightforward. You don't have to compare everything. It's just talking about the spread. Now the spread, let me change colors again, sorry guys, is referring to the range and the IQR. So when you see spread, okay, you just want to talk about range and the IQR. Okay, for both of these for both of these guys. Okay, so let me list out first the range for 2017. Okay, the range, remember, is just the maximum, take away the minimum. In that case, that's 42, take away 26. So for this one, the range is 42, take away 26, and that equals 16. So the range for that is 16. And then the IQR, remember the IQR is just Q3, take away Q1. So that would be 40, take away 35. Let's write that here actually. Range. And this is IQR. So 40, take away 35, which equals 5. Okay, so that's for 2017. Let's look at 2018. Okay, the range for this. I can see that's 44. So the range. 44, take away, and this would be 38. And that equals 6. So the range for that is 6, and the IQR for this would be 43, take away 40, which equals 3. Okay, and now we compare it. Okay, look at this question. It says use appropriate statistics. So you have to actually state numbers. Okay, and write down a conclusion that can be drawn from this comparison. So a little bit trickier in that it asks us to do a little bit more than what we've learnt before. But again, if you're able to just say, I'll write my answer here now. All right, so for example, let's just do this. So the range for 2017, actually instead of writing spread, range, I'll write the spread. Okay, is what it is here, 16 for the range. And what do we have for the IQR? 5 for the IQR. Whereas 2018 had 6 and 3. 6 and 3. So as a conclusion, therefore, 2017 has a greater spread. Than 2018. Now, because I've wrote a lot here, you don't necessarily have to write everything. Okay, I would say the most important elements to have in here would be the numbers. So you got to state the numbers for each one, and then just say that it's greater than or less than whatever the question might be asking you. Okay, that's really the main thing you need to have in here when you do these questions. All right, I'm going to skip this one, and I might go to the, oh, actually this one's good because it's got the rules. All right. Let's see which one might be better. All right, maybe do this one because, but this one might take me a bit longer only because it's got, I have to put on these numbers into a calculator. Okay, because we've got to get the formula here, but we'll go through it, and then I'm going to skip the rest and just go to the recursion questions. Okay, because we are running out of time, and I would like you guys to do that test, or the mini test. All right, this question here. The data below shows the age in years of 14 dog owners and the weight in kilograms of their dogs. Okay, scatter plot of the data is shown This data is used to investigate the association between weight and age. Okay, so it's sample of 14 dog owners and the weight in kilos versus the weight of their dogs versus the weight of their age. Okay, so it looks like here, the older the dog, or actually the older the, this is about the dogs. 14 dog owners and the weight in kilos. Okay. Okay, I guess it's the age of the owners. That's weird. But anyway, so the age in years versus our weight. So that means the older or the longer the years, the less the weight. You can see that it's going down. Okay, so it's in a negative direction. All right, so first question here, write the response variable, the RV. Okay, EV and RV, remember on your graph, EV is always on the X, RV is always on the Y. But also just make a note, sometimes it could be flipped around depending on the variable. You just got to think about, what are the variables saying? Does age determine your weight, or does your weight determine your age? In this case, I would say that the age determines the weight. So in that case, your response variable is the RV, which is here the weight. Okay, is there a question here? Sorry guys. Will the edited version be on OneNote, sir? Yes, all of this will be on OneNote, Elion. Describe the association, okay, of the variables between the age and weight and age. So when it comes to the association, okay, you have to talk about, remember, the strength, the form, and the direction. Okay, so what's the strength, what's the form, what's the direction? So in this case, you would say there is a, let's go blue. There is a, okay, what's the strength? I think that's pretty strong. So I would say there is a strong. Some of you might think it's moderate, but I think it's more strong than moderate, and we'll see when we put these variables in. There is a strong linear. Remember, linear means, can you put a straight line through it? If you can, then it's linear, and the direction is negative because it's going down. So there's a strong linear negative association between weight and age. Okay, there's your answer. All right, question part C. Calculate calculate R, Pearson's correlation coefficient. Round your answers to two significant figures. Now, this is where we need to rip out our calculator and put this in. So you might want to watch how I do it if you've forgotten how to. Okay, because we haven't done this since term 2. So I might start a new document for this. All right, so we're going to go add lists and spreadsheets. Actually, before we do that, you start here, go new document, lists and spreadsheets right there. Okay, so when you do this, make sure you name your columns. This is going to be called age, and we can call this weight. All right, so make sure you name your columns. So 56, put your numbers in. Make sure you don't skip on any, otherwise you might get the wrong answer. Okay, so put it in. By the way, if you left your CAS at school for charging, that's fair enough. However, if you left it at school and it's still in your locker, I would suggest that you charge it, or you take it home on Friday for after your English exam, and charge it, please. Okay, just double 14. Okay, so make sure you charge your CAS. Bring your CASs home over the weekend. Otherwise, you will not have battery for it for our exam. Okay, 11, 7, 13, 20, 12, 14, and 9. Okay, so there's my variables. I put it all in. Now, the question here is asking, find the value of R. So if you've forgotten how to do that, watch me do it. So you've put your variables in. Make sure that your cursor is not up here. Just put it like down here somewhere. I normally just put it to the right a little bit. just so that I'm sure that it's there. So to find your R value, you go menu, statistics, stat calc, and then we go linear regression A plus BX. Okay, I'll do that again. Or you can watch this again. So menu, statistics, stat calc, A plus BX. Okay, now from here, put your EV on the X list, RV on the Y list. So I know that the age was the EV and the weight was the RV. Okay, so there's my variables here. Okay, remember what each of them represent. So there is your, when you write your formula, that's what you'll be using, A and B. Oops, these two. But then here's your R and R squared. And my assumption was correct in saying that the R squared, or the R value, or the Pearson's correlation is going to be, or the association, sorry, is going to be strong. Okay, because the R value is negative 9.487. So here, two significant figures. So I'd write here 0.94, I forgot it already, 87. So to two sig figs, it would be 0.95. Okay, so, oh, actually, negative. Don't forget, it's a negative. So you would get that wrong if you didn't write negative. Okay. Determine the equation of the least squares linear regression. Write yes below and do it to 2 decimals. Okay. This is really easy. Remember, in any formula like this, let me rewrite this down here. It should look like this. Y equals A plus B and then times X. So in this case, A is here. B, oh sorry, this is A, this is B, and then this is your X, but yeah, your EV. So this is your EV, that's your RV. Okay, so in terms of writing your formula, oops. Okay, so if you look at your calculator, actually I'll put it here so you can see it. Okay, I can see that my A is 23.94, so I'll put that in. 23.94, and my B value, which is my y-intercept, is negative 0.259, but we'll run it to negative 0.26. Okay, because it says to 2 decimals. Okay, part E, explain why it would not be reliable to predict the weight of a dog which has an 89-year-old owner. Okay, so if the owner of the dog is 89 years old, why is it an unreliable prediction? Now, this is just an explanation as to why. Okay, you don't have to make the prediction, but you can if you want to. So if the age of the owner was 89 years old, what would the weight of the dog be? Well, let's have a look in our calculator. Okay, so let's add a calculator. My formula there is 23.94 plus negative 0.26 multiplied by, okay, we're looking for the age of an owner who's 89 years old. Okay, so what would the weight of the dog be? Well, you can imagine it'll be really, really, really light. It's an 800-gram dog, which does not exist. Okay, and it doesn't make sense. Also, if you look at the range of the values, you can see that the age in years, the maximum here finishes at around 60 something. I think it's like 62. Okay, so if you're making a prediction that's beyond, so higher than 62, okay, or less than, what's the lowest one? Less than 22, okay, it's going to be not reliable, which means that it's extrapolation. Okay, not reliable because it is extrapolation. You can say beyond the range. Of the data. Okay, it's beyond the range that's given us in the graph. Also beyond the range for the number, the age in years. Sorry, 68 is the highest. My bad. But regardless, it's higher than, well, 89 is definitely higher than that. So keep that in mind, please, when you do these questions. Interpolation is when you make a prediction within the range. Extrapolation is when you make a prediction outside of the range. Okay, so keep that in mind. when he asks you explain why. Or actually, there might be another question where it says make a prediction. Is it interpolation or is it extrapolation? Is it reliable or is it unreliable? Okay, let's keep going. I might leave these ones. I might leave these because it's already 9:36 and I want to give time to do some of these questions. And I might not do all of these recursion questions, okay? I might just do some of them, just the ones that I think would confuse the heck out of people. So that one's easy. This one's fine. I think, look, it's a basic V0 question. You're just going to add 320 each time. So that's easy. Questions? Any questions? I thought I saw a question. Okay. It's lagging. Okay, I'm gonna leave it at that. Let's go back. Okay, I'm gonna leave that one. Let's see. There, yeah, this one's easy as well, but I might just quickly do it. All right, let's do this one, and I'll do which one? Yeah, we'll do 4, 5, and we'll do 6. 4, 5, and 4, 5, and 7. I think. Did somebody have a question? Oh, okay, nope. All right, so I'll do 4, 5, and 7 for people so that they can get it. Actually, maybe I'll do 6 as well because it's got a unit cost. All right, let's get to it. Question 4. Okay, this one's really easy. Josh is a DJ and his equipment is depreciating annually. So that means it just depreciates every year. It goes down. Okay. Are there more questions, guys? I don't know if there are. Oh. So I see some questions here. Will the edited version be here? Yes, yes. I think I saw a question from somebody asking about the double periods. Oh, so I was wondering, this meeting says it will end at 10:55, but I remember being told the doubles were shortened to 1. Yes, they are shortened to just single periods, but you're still expected to do a little work in the second session, but you don't need to be online for it, Emily. So in the second session, I'm going to get you guys to do that test, and then, yeah, just complete it as quickly or as slow as you want because it'll finish at 11. But I'd like you guys to give it a go and see how you go with it. Okay, does that make sense? Let me just go through these. And yes, Leah said yes to Elion's question. All right, let me go through these, and then hopefully by then it'll be 10 o'clock, and you guys can start the mini test. Okay. He's a DJ. Equipment depreciates annually using reducing balance method. Okay, so reducing balance. This means that it's being multiplied. Okay, or it's geometric. Okay, keep that in mind. When you see reducing balance, multiplication, geometric. Okay, where Vn represents the value of Josh's equipment after n years of depreciation. On these axes below, plot the value of Josh's equipment between 0 and 4. So what this is saying is just what's the value of his equipment between 0 and 4 years. All right, so I'm a calculator. I'll start off. I can use my recurrence relation there, which I can see is starting at 12,000. So I can write that down here, 12,000 at the beginning times 0.85. So when you press enter, that's year 1, year 2, year 3, year 4. There's my values. So the first one is 12,000 right here. Second year is 10,200. So 10,000, what would that be? 200 would be around here somewhere. Okay, next one, 8670s. Year number 2, 8670. So that might be like somewhere here, I would say. It's really hard to gauge, but I would say somewhere here. 6, 7, 8. Yep. Oh no, that would be 9. Sorry, here. Okay, next one would be 73.69. So 73.567. That'd be about here. Not exactly on the line, but just a little bit above it. And then the last one would be 62.64. So that's about here. Maybe I would say here. Kind of hard to plot. Okay, so there's the depreciation in value after X number of years. Okay, how many years will the value be below 2000? Okay, all right. Someone else have a question? Oh, sorry, Bella. I'm so sorry. My bad. After how many years will the value of Josh's equipment be below $2,000? All right, we're up to year number 4. So if I keep pressing enter, 5, 6, 7, 8, 9, 10, 11, 12. 12th year, it'll be under $2,000. Sorry about that, Bella. Okay, what is the annual rate of interest of Josh's equipment being depreciated by? All right, now this one here is a bit tricky, but remember, how did they find, no, how do you actually get the R value here? So remember, if your R value, if it's increasing, remember you've got two different rules. So if you have an increasing R, it's going to be 1 plus percentage over 100. But if it's decreasing, okay, it's going to be R equals 1 minus percentage over 100. Now in this case, it's depreciating, so they probably used this. So the question is, what is the original percentage? Okay, what was this originally? So to find that, we know that the R value is 0.85, okay, is equal to 1 take away, what is that decimal? So what's the original percentage rate over 100? So on my CAS, I can actually just use my solve function for this. Okay, so if I do that, solve 0.85 equals 1 minus, and you can use, 1 minus, you can use your fraction if you like. You can get R over 100. Oh, one thing I forgot to put in here, comma R. Okay, don't forget that to find the R. So comma R. And the original rate was 15. So R was 15% originally. Write down a rule, okay? Write down the rule for the value of Josh's equipment after n number of years. So when you see the rule, it's going to be nth term rule. Okay, it's an nth term rule for this one. Now the nth term rule, when you're using something like this or a V0 question, remember it's going to be this. So Vn equals V0. This is for a geometric, yeah? So times R to the power of n. Notice how there's no more minus 1 there. Okay, in this case, the answer is going to be Vn equals 12,000 for the V0 times the R value of 0.85 to the power of n. Okay, there's my rule, nth term rule. Okay, that's all it is, easy. All right, any other questions? All good, okay. I don't think there's any other questions. All right, I'm going to skip this one because I think it was quite similar to this one in some sense. And we're already 15 minutes, okay. Let's go to this one. Courtney is saving money to replace her car which she purchased for $14,000 10 years ago. Okay, $14,000 10 years ago. Keyword there. All right, so I'm going to highlight that. It was 14 grand and this was 10 years ago. So you got to keep in mind what year we're in at the moment. Okay. Courtney's car has traveled 39,000 kilometers during the 10 years. If the car depreciated using the unit cost method of 32 cents per kilometer, find its current value. Okay, so what is the current value of the car at this given time? Now, in this case, you're probably going to want to use a rule of some sort to figure out the value of the car. But in terms of the rule, it does vary depending on the question. This is depreciating, okay? So because it's depreciating and it's depreciating at a unit cost, the normal rule you have for this is going to be V0 take away N times D. Okay, in this case, N is referring to the term, D is 32 cents. Okay, so in this case, the rule is going to look like this: Vn equals 14,000 take away N. So I'm looking for the 39,000th term, not the 10th term, yeah, because it says here it's 32 cents per kilometer and it's traveled this many kilometers. All right, so in this case, 39,000 times 0.32. Okay, so my calculator, this would be 14,000 multiplied by I put something there, my bad. I forgot to put multiply. Multiplied by the 39,000. 1, 2, 3 times point. Oh, it was 32. So the value of the car now. So if you get that, just press Control and I put times. Yeah, I put times. Thank you, Keaton. There you go. That's better. 1520. 1520. All right, easy. It is okay. So now that's one part of the question. Next part is it is decided instead that the car will depreciate using reducing balance. All right, now keyword here, reducing balance. It's going to be a geometric type of question now. Okay, it's going to be multiplied by something. So in this case, and it's at 50% per year. Per annum just means per year. All right, that's pretty easy. So let's see represent something. So, okay, let represent the value of Courtney's car after N years. All right, I think it should be Vn. Write down a recurrence relation for this in terms of years and model what that models the value of the car. All right, so there's two things here we need to state. Remember, when you do a recurrence relation, you got to tell me the starting term. Okay, and then what's Vn plus 1. So how do you get the next term? So in this case, because it's reducing balance, it's going to be Vn times whatever the R is each time. Okay, so in this case, one thing I want to make a point out is whenever you get a question like this, people just tend to give me this as an answer. This is incorrect. Okay, as in this, you can't just write this. That's not the actual answer. Okay, there is an actual, this is the format of what your answer should look like. And I found that in people's sacks, okay, this is the answer that you all have been giving me. Or sometimes you gave me this as an answer. Vn equals A plus N minus 1 times D. Okay, this isn't just the format of what your answer should look like. Okay, this is not itself the rule, for example, or this is not itself the recurrence relation. It's just the format. So keep in mind that when you get a question where it asks you to write the recurrence relation or the rule, these things here, this is just what your answer should look like, but not what the answer is. Okay, just the format of your answer. So in this case, okay, we're going to write down the answer in the actual way. This is what it should look like down here in the red. Okay, what it should be, sorry. So in this question, the starting number or the starting term is 14,000. So I can start with that. 14,000. Now, how do you find the R value? So to find the R value for these sort of questions, okay, so this is going to be a reducing balance, okay, and it's not flat rate, okay. So when it's reducing balance, when you're trying to find the R value, you're going to be using either the R equals 1 plus percentage over 100, or if it's going down, 1 minus percentage over 100. And because this is depreciating or it's going down, we're going to use the 1 minus. So in this case, it'll be 1 minus that 15%. over 100. And that gives us 0.85. Okay, so my R value is going to be 0.85. Okay, and then what is the current value of the car in this scenario? Now, again, current value of the car is referring to what's the car's value after 10 years, because she bought the car 10 years ago. Okay, so what's the current value of the car after 10 years? Now, you can use a recurrence relation for it. So, using your calculator, okay, we're at 14,000, so that's year 0, and the recurrence is times 0.85. So times that by 0.85. So there you've got year 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I think I went too far. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there it is. I went too far by 2 years. Okay, so there's the 10th year right there. 2756.24. So V10. So that's the value of the car after 10 years. All right, let's just do one more, guys, and then that'll be it. Okay, because, yeah, last one. What's the time? 9:52. Okay, we can smash this out in 8 minutes. All right, let's do this. Courtney borrows 30,000 to buy a new car. So keywords there already. Oops. 30 grand. Buy a new car, and there's interest rate charged per annum. Okay, so the yearly interest rate is 6.2, but it's compounding monthly. Okay, now this one is a little bit more involved. Okay, there's compounding monthly. It's a compounding question. Okay, so find the balance of Courtney's car loan after the 1 year. Okay, so if she borrows a car, if she borrows money, she's got to pay it back, which means that this is going to be increasing. Okay, where did my mouse go? She borrowed 30 grand, it's going to be increasing. Okay, now after 1 year, all right, we've got to figure out the value of her car. There's a few things that we need to figure out here. We need to know what's the interest rate. So if it's compounding monthly, okay, you can see that here. Okay, what's the interest rate per month? So how much does she have to pay every month? Okay, in this case, it's 6.2 for the whole year. So to find the rate, so the R value, if it's compounding, you remember it's going to be 1 plus the percentage rate divided by the number of compounds over 100. Okay, and you'll remember this back to when I think towards the last few chapters, or the year 12. This is a year 12 question. Okay, so what's the R value for each compound? That's what this is asking. So in this case, it's going to be 1 plus 6.2 divided by the number of compounds. In this case, it's monthly. So what that means is there's 12 compounds per year divided by 100. That looks like a 1. So my calculator. 1 plus, use your fraction button if you want to, 6.2 divided by 12 over 100. So the R value, okay, and your R values always tend to look like this, yeah, if it's compounding. So 1.00517. Okay, now the question here is asking us what's the balance of Courtney's loan after 1 year. So on my calculator, I'm going to use this as my new R value. You're starting at 30 grand. Okay, 30,000, and you're going to be adding a compound interest or multiplying it by this R value. Okay, and we're looking for it after 1 year. So how many terms is that? If it's compounding monthly, that means it's it's after 1 year, it's 12 terms because it's monthly. So we're looking for the 12th term. So it's going to be term 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's your 12th term, 31913.8. Okay, so that's the value of her, that's the balance that she has left to pay after 1 year, which is 12 terms. How much interest does she pay during the first year? So in terms of interest, all you're going to do is how much does she have at the moment take away how much does she have at the start. Okay, so in that case, it'll be 31913.80, take away 30 grand, and that would equal 1913.80. Okay, after the first year. What interest rate per annum would Courtney need in order to only pay $1,000 in interest during the first year with the same compounding periods? Now, this is a tricky question, okay, because now we need to figure out what's the interest rate that she has to pay per year, okay, in order to only pay $1,000 in interest. Okay, now we need to figure out first what's the rule that we can use to actually find how much interest she'll have to pay. So in terms of a rule, okay, remember the rule, if it's a depreciating or if it's a question like this. So if you get a question like this, remember that the generic rule for it is going to look like this. So it's going to be Vn, okay, equals a V0 multiplied by whatever the R to the power of N is going to be. This is the generic rule for it, okay? So we're going to use this rule and put it in this format for this question. So Vn equals V0 times R to the power of N. So the rule is going to be Vn equals 30,000 times R to the power of, I'll show you, the R was 1 point, what did we say it was? 0.00517 to the power of N. Okay, now the question here is, what interest rate per annum would Courtney need in order to only pay $1,000 in interest during the first year with the same compounding periods? Okay, this one gets a little bit tricky because if you remember back to the notes, the rules that I wrote for you guys. So if I just open up, where is it? Collaboration space. Oh no, sorry, content library. So if I go to recursion, there it is. Okay, I think only one person did this. So what I'm going to use for that, for a question like that, I would use this rule. Okay, it looks a bit crazy, I know, but all you have to do is in this rule, just change for the variable that you're looking for. Okay, so if you're looking for a percentage, or you're looking for VO, or you're looking for the number of compounds, use this rule. Okay, and you put it in your calculator. So I'll quickly just copy this so we have it. I want to copy it in here. Where is it? Sem1 exam, I think it was. Exam revision, yeah. Quickly put it here for you guys. Oh no, where did all my writing go? Have I been writing in someone else's? I think I have. Yeah, all right. Yes, I don't know where it's gone. Sorry, guys. Anyway, I'm just going to do this question. In any case, you can watch the recording anyway. So I'm going to paste it here. This is the rule that I'm referring to, okay, that you're going to use. So in this case, if you write down the rule, it's going to be solve. Now, think about this. If you only want $1,000 in interest for the first year, how much money will you have in that time? Okay, so if you have 30,000 plus 1,000 in interest, then it has to be a value of 31,000 equals V0, which is 30,000 times 1 plus. Now, that's what I'm looking for, this percentage rate. Okay, so percentage rate divided by the number of compounds is still 12 over 100. Close the bracket, to the power of 12 times 1. Okay, now I'll write 12 times 1 because its n is referring to the number of compounds and it's still only after 1 year. T refers to the year, comma R. So if you put that in your calculator, solve 31,000 equals 30,000. And I think only one person used this in the actual SAC, 1 plus. Okay, usual. So you've got r, I'll use r divided by 12 over 100 to the power of 12 times 1, comma r. And this will give us, so if it looks like that, just press Control Enter, and the percentage, okay, I would say it's this one, 3.28, okay, because that's a crazy number. So the R value, or the rule, or the percentage rate per annum is 3.28. Okay, so if you get a question like this, that's when you most likely will need to use this rule. Okay, and I gave you guys that rule in our for our recursion unit. All right, I'm going to stop there. It's 10 o'clock. I've talked a